number 19. So we have 3x minus 1 over 2x squared plus x minus 6. So this one is not already factored. Sometimes they come factored, sometimes they don't. This one did not. So let's start by factoring it. Factor the denominator. So we factor it and we get, I don't know, this one's a hard factoring problem. 2 times 6 is negative 12. So to get a 1 in the middle, we would have a positive 4 and a negative 3. So if we put a 2 here and a 2 there, that gives us a positive 4. Then if we put a 3 here, then that would give us our negative 3, which gives us our positive 1 in the middle. There's other ways of factoring, and I don't think you have to worry about factoring on the one on the final. But anyway, so these are both linear factors. That means we would simply set this up as a over 2x minus 3 plus b over x plus 2, and we would use whatever method to find a and b, and we would then rewrite our answer like this with numbers instead of the a and the b, right? I don't think it'll take us very long. Let me go ahead and figure that out. So if we go ahead and get rid of the fractions, multiply by our least common denominator. So it would be a times that denominator and b times this one. It kind of ends up just being like a cross multiplying to get rid of those denominators. If you've done enough of these, you probably understand why I did that, and I'm just kind of shortcutting at this point. Okay, so then to get rid of a, I'm going to let x equal a negative 2. And then I just plug that in everywhere that there's an x. So 3 times negative 2 minus 1 equals a times negative 2 plus 2, so that's 0. And then b times 2 times negative 2 minus 3, so that's a negative 7, right? So that gives me negative 7 equals negative 7b, I think, if I did the math right. So that tells us that b equals 1. All right, then for the second part, I would let x equal 3 halves. That's kind of ugly. Oh well. So then we would have 3 times 3 halves. I don't know if we want to do it this way because the fractions are always a good time. Let's see, 3 halves plus 2, and then b times, let's make sure this actually worked like I wanted it to. If I'd use 3 halves, that gives me 2 times 3 is 6 divided by 2 is 3. 3 minus 3 is 0, right? That does make that cancel out like I wanted it to, right? So it's worth all the fractions everywhere else. So this would give us 9 halves minus 1 equals, here I should get a common denominator here. So 9 halves minus 2 halves would be 7 halves. And then this one plus 2, so that would be adding 4 halves. It ends up not being terrible. Oh, so a also equals 1. So the answer is 1 over 2x minus 3 plus 1 over x plus 2. Okay, that's all well and good. That wasn't a hard problem, da-da-da. Now, for what you need to know, it's less about how to factor and less about how to solve for a and b and whatever, and it's more about making sure you know how to set up the problem. So for example, if you had something like, I'm just going to make something up, 1 over x plus 3 times x squared plus 4 or something like that that doesn't factor. It's an irreducible quadratic factor. Maybe we should actually say that this one's a repeated factor. Do you want that one to be repeated too? Maybe we shouldn't mix too much stuff in the same problem. I don't know. So the linear factor, we just have an a over the top with a linear factor. But for the quadratic factor, we would need a linear numerator. So bx plus c over x squared plus 4. That's because your numerator always needs to be a degree less than the denominator. So if it's an irreducible quadratic factor, we have to do that. Do you remember that from when we did that lesson? So just make sure you remember how to set up those special cases.
So we don't even have to solve it on the bed.
Nope. You didn't hear it from me.